Good morning, everyone. This is Somshekhar from the Department of Basic Science and Humanities. Uh, and my subject is physics. Today I am going to discuss about classical free electron theory. What is this classical free electron theory? The classical free electron theory is initially started to understand the structure of metals. So, what is the structure of metals and how the electrons are existing inside a metal? So initially there are so many theories or regarding with the structure of metals, and they thought that the metals are electrically good conductors and a proper structure is there as a periodic structure. Whereas in case of non-metals, they have no proper structure and there is no good electrical conductivities. But they are having some problems regarding with the structures of these metals and non-metals. We know that the mercury is a substance which is having no proper regular structure. However, it is a good metallic properties. Whereas in case of graphite, which is having a good electrical conductor, where it is not say it is behaving as a non-metallic characteristics. It is a non-metal. So to avoid these confusions, there are some theories which are started by in the 19th century, and one of them is classical electron theory. And this classical electron theory was proposed by was proposed by Drude and Lorentz. Drude and Lorentz. This Drude and Lorentz has initiated the structure of electrons inside a metal. The structure of electrons inside a metal, and those electrons and those electrons have those electrons have and those electrons will have, there is a comparison of known to unknown comparison theories. And Drude Lorentz has assumed that the electrons inside a metal are similar to gas molecules in a closed chamber. So they compared that the metal electrons inside a metal are similar to gas molecules in a closed chamber, whereas the electrons are free to move in all directions about the whole metal volume, whole metal volume of whole metal. And the third postulate which they proposed, in the absence of electrical field, the electrons move in random direction, making collisions from time to time with positive ions which are fixed at lattice or their free electrons. All collisions are elastic in nature. When an external field is applied on the free electrons, they are slowly drifting towards the positive potential. Since the electrons are assumed to be a perfect gas, they obey the classical kinetic theory of gases. And classical electron theory in the metal obey Maxwell's Boltzmann statistics. So we are going to discuss about these points as more clearly as that. See, the classical electron theory, which is first initiated by Drude Lorentz in 1901, and they postulated about the classical electron theory. That means the metals inside the electrons inside a metal. So the electrons inside a metal are first point. That is the first point, as they discussed, is that the electrons in a metal are similar to gas molecules in a closed chamber. So how we can say that this one is, let us take. See, a metal which is having a regular periodical structure, regular periodical structure of atoms. So this is one atom, another atom, and this is another atom. And these atoms have, which we can call it as a space lattice. So we can define the space lattice as the regular periodical arrangement of array of atoms. And the electrons inside the metal are not desired to a particular atom. They can have the random motion. And this electron motion is similar to gas molecules in a closed chamber. See, the gas molecules will have a random motion. So this is from kinetic theory of gases. This is from kinetic theory of gases. And the electrons inside a metal also having the property of kinetic theory of gases. And that second postulate, which we can call it as, see, the electrons are free to move in all possible directions inside the whole volume of metals. They can have the random motion. And now we can read it as, and the third one is, there is no external electrical field or voltage is applied on the metals. They can have collisions with the surrounding positive ions. They can have the collisions with the positive ion cores. So those collisions are elastic in nature. And the fourth postulate, when an external voltage, which is nothing but a field, is applied on the electrons, they can slowly drift towards the positive potential. Means, for example, if you can take a positive plate and a negative plate, so this is a negative plate, and the electrons inside the metal will move from this negative plate towards the positive plate. So this way they can propagate inside the metal. Since the electrons are assumed to be a perfect gas and they can obey the classical electron theory, and they have a velocity, and that velocity obeys the Maxwell's-Boltzmann statistics. So by using above theory, we can calculate the conductivity of electrons inside the metal. So for that purpose, let us start. We know that the famous Newton's equation, that force F is equal to ma, and Lorentz equation, F is equal to minus E bar. So this F is equal to minus E bar, or F is equal to QE, which we can call it as Lorentz equation. F is equal to QE bar, which we can call it as Lorentz equation. And the Lorentz equation, which states that when a charged particle under external field experiences a force, and the force is given by F is equal to QE bar. Whereas from Newton's laws of motion, F is equal to ma. By comparing the two equations, we should understand that the acceleration of the electrons is given by A is equal to minus E bar by m. So we know that the acceleration is nothing but rate of change of velocity. Let us take the velocity attained by the electrons. Due to external field is called as drift velocity. So which we can represent as Vd, which we can call it as the drift velocity attained by the electrons. Vd is called the drift velocity is attained by the electrons, and the acceleration A is equal to Vd by tau, where Vd is the drift velocity and T is the time which we can also tau, which we can call it as relaxation time or mean collisional time. That is the average time required between two successive collisions. So now I can replace this acceleration as Vd by tau, and I estimated the value of Vd, which we can call it as the velocity of drift velocity as a drift velocity, which is equal to Vd is equal to minus E bar tau by m. And we know that the current density, since see, as we know that current density J is equal to by A, I by A can be replaced as J is equal to minus NEVD, where N is called carrier concentration. Where N is called carrier concentration. It stands for number of electrons present in unit volume. Number of electrons present in unit volume. And E, charge of electron, and VD is drift velocity. As we estimated that drift velocity in the equation 5, we can have J is equal to minus NE into minus E bar tau by M, or J is equal to NE square tau by M times of E bar. J is equal to NE square tau by M times of E bar. So, but as the definition of sigma or conductivity, sigma is equal to J by E. So then that sigma is equal to J by E stands for, then the sigma is the conductivity, which is having the value of J is equal to NE square tau by M. So, or the resistivity of the metal, which we can given by M by NE square. So the classical free electron theory have made some conclusions, which are called as sigma is equal to Ne square tau by M, where N is the number of electrons present per unit volume. So if there are n number of free electrons inside a metal, and those free electrons as increases, the conductivity of the metals is increases. So the metallic conductivity property is depends on number of free electrons. And the second factor which influences the conductivity of a metal is relaxation time. So as it states that if there is number of collisions or increases inside a metal, there are n number of collisions or increases inside a metal, the conductivity is also decreases. So the conductivity is depends on the less number of collisions. Means the mean collisional time is more. That means very less number of collisions are possible inside a metal, which creates a increase in conductivity. So as it's in turn, it relates with as the temperature increases, as the temperature is increases inside a metal, as the temperature increases inside a metal, automatically the number of collisions increases and the mean like collision time is also increases, then automatically the conductivity is decreases. So it is a pattern of depending on the collisional time as well as number of free electrons available in the metal. So if you can compare with copper and other substances, the copper will have more free electrons. It will have a good conductivity. Whereas in case of certain substances like some insulating materials, those will have less number of free electrons and they could not possess more freeness, or that means there is a less conductivity or no conductivity, which is explained by this classical free electron. And not only that, it has a success. And what is the success of this theory is that it verifies the Ohm's law. So according to that Ohm's law, as the voltage is increases, that means the applied voltage is increases, automatically the number of free electrons and the conductivity, in turn the current is increases. So from the Ohm's law, which we can state that V proportional to I means as the voltage, that means in turn the electrical field intensity increases, the conductivity is increases. Also, as I discussed with you, that it explains the electrical and thermal conductivities. That means the conductivity or electrical conductivity is inversely proportional to temperature. So as the temperature is increases, number of collisions increases, and the electrons will take more time to reach the other end. And that means the electrical conductivity decreases. And finally, it also refines is that it also derives the Weidmann and French law. So that is the relation between electrical conductivity, as the second point we discussed, Similarly, it has a pure relation that will be given by the Weidmann and French law. And also it explains the optical properties of metals. So these are the some success of this classical free electron theory. Now we are going to discuss about failures of the classical free electron theory. So the classical free electron theory, see, generally we can say till now it not explained about the existence of bands and it not explained about the differences between conductors, semiconductors, and insulators. So basically, the conductivity of a metal or the conductivity of a semiconductor is always depends on the number of free electrons available in the valency state or valency band. So we know that the conductivity should be directly proportional to the valency electron concentration. It is not explained by this classical free electron. And coming to that, electrical properties of alloys should be intermediate between the values corresponding to pure metals. However, alloys have a resistivity which are considerably larger than those either pure constituents. We know that. See, if the semiconductors will have different properties. In the semiconductors, as the temperature is increases, in the semiconductors, as the temperature is increases, their conductivity is increases. There is no proper explanation with alloys as well as semiconductors in the classical field electron. And also it depends on the resistivity on temperature. And also it depends on the resistivity on temperature. And according to that, we know that the resistivity is some sort of relations of T power 4 P power 4 relations or T square T power 1 by 2 relations are some relations which could not be explained this root state. Okay, so these are the some sort of drawbacks by the classical electron theory. However, it should be explained some proper explanations on existence of electrons inside it. So these are the concepts regarding with the classical electron theory. So, however, the classical electron theory have some shortfalls. This will be or try to overcome by the quantum electron theory, which is proposed by Sommerfeld. And the assumptions of quantum electron theory is one, the energy of electrons is quantized. It will start that quantum mechanical assumptions. We know that electrons are possess a quantum mechanical states, which we can represent with what a particle in box or a potential well, which should be assumed as these particles, and the distribution of electrons among various permitted energy levels as per the Pauli's exclusion principle. So all these laws can be governed by the quantum mechanics, and that quantum free electron theory supports that quantum mechanical laws. That means the electrons inside a metal can obey the quantum mechanical laws. So similarly, the electrons can travel in under the constant potential, or the potential inside the metal, the electrons will have zero potential. They can have a zero potential inside the metal. As they can have an external field, they possesses that external voltage. Till now, the potential energy of the electrons is zero inside the metallic substances. So now coming to that, classical the attraction between lattice ions and electrons as well as repulsions between the electrons are neglected. Here, the quantum free electron theory will have some sort of nature. That means the attractions or the collisions which cannot be considered inside a quantum free electron theory. Finally, the classical electron theory permits all electrons to gain energy, but quantum electron theory permits only a fractional electrons to gain energy. So these are the concepts regarding with the quantum electron theory assumptions. So just now we will go the briefing of this today's topic is. So first of all, we started the theory of classical electron theory. So to understand that classical electron theory, so The classical electron theory, it is proposed by Durand Lorentz in 1901. They had given some postulates, and that postulate is compares the known to unknown as the electrons inside a metal are similar to particles in a gas molecule. The electrons are free to move in all possible directions about the whole volume of metals, and as we know that in the absence of external field, they can have the collisions with the surrounding atoms as well as walls of the metals, and all the collisions are elastic in nature. And finally, they have some, if they have uniform potential, if you can apply an external voltage, they will get some sort of energy, or they will get some sort of potential energy. Now, finally, so the electrons are assumed to be a perfect gas. They obey the classical electron theory assumptions, and kinetic, they obeys the kinetic theory of gases. Classical electron theory of metals can have obeys the Maxwell's Boltzmann statistics. So these are the assumptions, and from that we can conclude the answer. Thank you, and providing this opportunity. I will thank the management of RITE and Honorable Chairman Sir Dr. Ratnakar Garu and Principal Sir Dr. C.H. Narasimha Garu for providing this opportunity to give a guest lecture on this topic.